Hello everyone. In this talk, I will introduce our recent work about gravitational waves from a gauge field non-minimal coupled to gravity. I'm Jian-Feng, and the co-authors of this work include Chern-Simons, Zhang, Zhongguan Guo. This is outline of my talk. Since our work is based on the standard axion inflations, I will briefly review it. In the second part, I will introduce the actual mode used in our work, and finally, I will make a simple conclusion. This is the notation conventions used in this talk. I will use the standard FRW metric and use T to represent the cosmic time and tau to represent the conformal time. The dot represents the derivative with regard to the cosmic time, and the prime represents to the derivative with respect to the conformal time. The cosmic time and conformal time is related by d tau equals dt divided by a. And I will use the standard h to represent the hyperparameter of the cosmic time, and use the calligraphy h to represent the hyperparameter with respect to the conformal time. This is the action of the standard axion inflation. The action includes a scalar field, a pseudo-scalar field, which is inflated, and also an axion. And there are also a gauge field. The gauge field and the axion-like field is coupled through the Chern-Simons term, where the tilde represents the dual of the gauge of the F. Since the dual will change the parity of the field, when we make a parity transformation, the F tilde term will have an actual minus sign. And since the phi is an axion-like field, it have odd parity, which means under the parity transformation, it can also have an extra minus sign. Those two minus signs cancel each other, so the total parity of the Chern-Simons term is still even, which is why we can safely put it into the action of the model. The next formula is how we decompose the gauge field. Firstly, we will transform it into the Fourier space, and the next we will decompose it under the basis of the circular polarization. The main feature of this basis is when we cross product it with k, which represents the propagate direction. We will got the different thing, which represents the different polarization direction. The one is the left hand, and the another is the right hand. So if we write down the equation of motion of the gauge field and cast it onto those spaces, we can have an actual masters which have a plus or minus sign depend on the scalar depend on the gauge field is left or right-handed, where the psi parameter is defined by r times phi dot and over 2fh. It roughly represents the speed of the axion field. We know this term appear as an effective masters. So since we have plus and or minus depend on different polarization, one can expect for one of the polarization, those effective mass can become negative, and therefore exponentially enhance the gauge field. The last one of this page is an analytic approximation of this equation of motion. However, note these formulas only valid when psi is nearly a constant. Anyway, one can note there are an exponential with respect to the psi. So although this is just an approximate solutions, it also reflects the main features of this equation. Next, one can derive the energy moment tensor from the action, and we can got the energy density from its zero component. The physics meaning of this energy density is easier to understand. The first part is just energy density of the phi, and the last part is the energy density of the gauge field. In this page, I transfer it to the notation of the electric and magnetic field. Okay, but note, although I see the electric and magnetic field, it only means the corresponding part of the gauge field. It does not means there is a physical electric and magnetic field. So with the action, one can also find the equation of motion of the background evolutions. Note here the electric and the magnetic field is enclosed with a bracket. Those brackets represent the average over the symbol. It since in this model the gauge field is be treated as an fluctuations. Such average represents the back reaction from the fluctuation to the background. And we'll note those average is an integral. So this system is in fact an integral differential equation systems. To solve it, it generally requires some special techniques, and especially since I just introduced, the gauge field production is related to the velocity of the axion field. So if the velocity of the gauge field is large, there are many gauge fields produced, and therefore the backreactor will get strong. So in those cases, the backreaching effect cannot be ignored. Finally, this is a formula about how to compute the tensor spectrum from these models. Firstly, we can derive the energy moment tensor of the electric magnetic field, and we put it as the right hand side of the equation of motion of the gravitational waves. So it can be explained as a source to produce the gravitational waves. Then, since at the left hand side, the Green's function is easy to obtain, we can obtain the solution of the H by integral over the source and the Green's function. So the last time is a general form of such solutions without any approximation. Finally, once we obtain the solution, we can compute its vacuum expectation value, and here shows a very rough estimation of the tensor spectrum. It's only valid when the psi is small, and those formulas usually get a higher value than the actual spectrums when the psi is large. And one of the feature is we note in this formula the plus mode is much larger than the minus mode, which means the gravitational waves induced by the gauge particle production is also carry asymmetry. So in some research about the gravitational waves, some people will also define delta chi to describe the parity broken features. However, in our research, these features is not what we focus. So next is our actual mode used in our papers. So first, where is our non-minimal coupled term motivated? So in fact, such terms is motivated by the gauge field action in the of the QED in the curved spacetimes. One can imagine our electron have a constant wavelength, and if our spacetime is strongly curved, it's made comparable to the constant wavelength of the electron. So in that case, the electron can feel the curvature of the spacetime, and therefore we can add the coupling between the electromagnetic field and the spacetime curvature. Such action can also be extended from the point of view of effective field theory, where the the mass of the electron, should be treated as an cut-off energy. And so when the cut-off energy is much higher than the space-time curvature, which means the constant wavelength is much shorter than the space-time curvature. So in this case, the corresponding will be surprised, and so therefore we cannot think. And however, in our inflation case, we are not use the QED, so we need have a different physical explanation. So we will explain the action used in our study as an effective field theory, and use the energy scale of the inflation as a natural energy cutoff scale. So here is the actual action used in our model. So in our models, the action is no longer an inflaton, but is a spectator, which means its energy, both the kinetic and the potential, is much less than the energy of the background inflaton. And as usual, the action is coupled with the gauge field with the Chern-Simons term. However, we note at the last term we append an B over 4 RFF term, which is just the non-minimum curve we mentioned at the previous page. And the potential of the phi is just a standard Star-Robinsky potential, and the potential of the chi is a quadratic potential at sign structures. Such potential, if we plot it, it looks like this. At the near the middle of this plot, we can find a rather rapid roll stage. So at this point, near this point, the velocity of the action field is much larger than any other point. So we can expect there should be a peak of the gauge particle production. So here is the equation of motion of our actual model. So the first part of the equation motion is very similar to the standard axion inflation, except for this in this time our axion is a spectator but not inflation. However, we can note our non-minimal couple term correct the energy density and the pressure of the background. However, our compute shows the correction in the energy density and the pressure is not so important. In fact, the backcorrection effect will first influence the evolution of the chi rather than the evolution of the scale factor. So next, this is the equation of motion of the gauge field, and this is the most interesting part of our research. We find after adding those non-minimal coupling terms, there will have a correction to the mass term of the action of the original gauge field. And since our correction is happened on the tachyonic mass, we can expect it can exponentially influence the gauge particle production. However, it also introduced an actual fraction terms, which means our formula of the BD vacuums should be slightly changed. And usually, in our work, we set the B to be a minus number. Therefore, the 1 plus BR is general a number smaller than 1. So this part, so this correction will bring enhance of the effective mass. So if we put those two effects together, we will find firstly the effective mass will be enhanced, but the overall it also will bring an overall factor due to the correction to the BD vacuums. However, the surprise of the BD vacuum is roughly polynomial, or says it's root square, but the enhanced effect is an exponential. So our total effect is it's still an exponential enhance of the particle production. So this is our numerical results, and with the different coupling constant from the weak to the strong. Since our computation is already included the back reaction, when the particle production is large, it will first slow down the velocity of the action field, and which will lead to the decreasing of the particle production, and the back reaction therefore reduced. So since the action have less fraction, it will accelerate again, which will generate such oscillatory patterns of the velocity of the action. And this is the gravitational waves computed from our models, and also the coupling constant is from weak to strong. And we find with the coupling constant get stronger, the gravitational waves also exponentially enhanced. And the double peak structure of this paper curve is due to the back correction. Since as there the back correction is strong, it will lead the oscillatory of the velocity of the action, just as what I shown as the previous page, and therefore it will reflect it in the final plot of the gravitational wave spectrum. So finally, let me make a conclusion of this talk. I first introduced some basic phenomenology of axion inflation, and next I discussed the motivation of the nominal gauge field gauge gravity coupling on RFF used in our study, and explained it with the effective phase theory point of view. Then I discussed the influence of this coupling term, and found it can exponentially enhance the gauge particle production. So where I we set the coupling constant to negative. And at the last, we calculate the equation of motion numerically and include the back correction, and found an oscillatory patterns for velocity field and gravitational wave energy spectrum in the back correction region. So that's all. Thanks.